Hello guys, so now we will be studying about covalent bonding in chemistry because we have already gone through the ionic bonding in our last class, right? So I hope everybody have done those orbital diagram, electron dot diagram of ionic bonding, right? And there is some ionic equation that was also there in the ionic bonding. So if you haven't gone through that, please go through that, then come back to this lecture. ठीक है, so we are going to have this lecture, you are going to write down, understand everything, then definitely on this we are having a live class this weekend. Okay guys, so let's start covalent bonding. Okay, it is already, I have already made something for you, so I'll just explain the things that is written over here. I'll use this. Okay, so covalent bonding, co means sharing. What is co means? Co means two people are coming together, right? So co means basically sharing. Valent means valency. The kind of valency that covalent bonds show is called covalency. This co word or the co term means mutual sharing of valence electrons. Mutual sharing of valence electrons, that is what covalent bonding is and nothing else. So you can write the definition at this moment. Definition is chemical bond formed by mutual sharing, chemical bond formed by mutual sharing of valence electrons to achieve nearest noble gas configuration or the state of minimum energy. This is the perfect definition that you can get for covalent bonding. Okay? Mutual sharing of valence electrons to achieve nearest noble gas configuration or state of minimum energy. Okay guys, so that is what covalent bonding is. So I have also explained how this thing, from this term you can decipher what covalent bonding is. Clear? So first of all, covalent bonding is shown by non-metals. Covalent bonding is shown by non-metals. There are certain metals which also shows covalent bonding, like your aluminium sometimes, lithium. Okay, so there are certain exceptions of metals showing covalent bonding, like lithium, aluminium, they show sometimes covalent bonding. Clear? So generally this non-metals have 4 to 7 valence electrons in their valence shell, right? 4 to 7. But again there are some exceptions, like boron has 3, hydrogen has 1, has only 1 valence electron. Okay? Now there is, but normally 4 to 7. Okay? So normally as there are 4 to 7 valence electrons, they cannot lose so many electrons owing to the attraction due to the nuclear charge. Okay? Suppose I am having 5 वैलेंस इलेक्ट्रॉन्स. ओके, सो एक वैलेंस इलेक्ट्रॉन आप निकाल दिए तो मेरा क्या होगा, अभी कैटायन हो गया है ना. सो 5 वैलेंस इलेक्ट्रॉन्स है, सपोज देयर आर 5 वैलेंस इलेक्ट्रॉन्स. ठीक है, नाउ 1 वैलेंस इलेक्ट्रॉन इज टेकन आउट, सो दिस इज x, 5 वैलेंस इलेक्ट्रॉन, सो इट बिकम्स x प्लस. Definitely this is a cation, and in periodic table we have already learned when it loses 1 electron it becomes cation, its size becomes smaller due to higher nuclear charge. सपोज यू टेक आउट अनदर, चलो और एक निकाल लिया. ठीक है, तो अभी हो गया x2 प्लस. ठीक है, तो नाउ इट हैज ओनली 3 वैलेंस इलेक्ट्रॉन्स. नाउ इट विल बी ऑलमोस्ट इम्पॉसिबल टू टेक दिस 3 वैलेंस इलेक्ट्रॉन्स बिकॉज द न्यूक्लियर चार्ज दैट इज स्टिल सेम एज इट वॉज देयर इन दिस इज पुलिंग दोज 3 वैलेंस इलेक्ट्रॉन वेरी टाइटली. सो इन केस ऑफ हायर नंबर ऑफ वैलेंस इलेक्ट्रॉन्स, विच इज द केस ऑफ नॉन मेटल्स, they can't lose many electrons overcoming the attraction due to nuclear charge. ठीक है, so what do? They also have to combine. So they combine with each other to share and achieve noble gas configuration. So what they do? They combine with each other to share their electrons. They don't give away their electrons. Okay, they don't give it completely. They just share their electrons to achieve, here it will be nearest noble gas. Please write nearest noble gas, nearest noble gas configuration. Clear? So let us now understand what is covalency. what is covalency. So we have already learnt what is electrovalency last class. Now covalency, number of electrons, please write down, number of electrons shared during formation of a covalent compound, is called covalency. Okay? Now we will take 3 examples. So we will take hydrogen. So first of all, what is the Lewis dot diagram of hydrogen? Like this, right? And this is also like this. Okay? This two get added and form hydrogen molecule. So when you show the molecule, it will show like this. That means these 2 electrons are shared by both the hydrogen. It is like this. It is within this also. It is within this also. So here there are 2 electrons forming a covalent bond. Okay? 2 electrons forming a covalent bond. In this bond, one of the hydrogen atom has contributed single electron. So covalency here is, covalency of hydrogen here is 1, because in the total sharing, hydrogen alone has contributed, one hydrogen has contributed 1 electron, and this is a single covalent bond. This is a single covalent bond. Single covalent bond. This is a single covalent bond. Clear? So now we will be doing the next one, that is oxygen. So what is the electronic configuration of oxygen? It is having 8 electrons, 2, 6, correct? 2, 6. So we will write it like this. So it needs how many more electrons? It needs 6 electrons you have to show in Lewis dot diagram. 2, 6, only the valence electron you have to show, and here also same way I will write. Okay? Plus. So both of the oxygen atom at this moment require 2 electrons to achieve octet configuration. Hydrogen will achieve duplet configuration, it has achieved. Okay? But oxygen will need octet configuration. So O, this is like this only. Here like this you have to show. So at this moment, how many total number of electrons are there? How many total number of electrons are there? That you need to understand. How many total number? Here it is basically, this oxygen is having now 8 electrons and this oxygen is also having 8 electrons. But in the bond, how many total number of electrons are there? There are 4 electrons. Okay? Always remember, number of bonds is equal to total number of electron participating in a covalent bond divided by 2. Okay? 2 electrons means 1 bond. So here there are 4 electrons. So this is an example of double covalent bond. Double covalent bond. Okay? This is an example of double covalent bond. And what is the covalency over here? Covalency is basically, you have to consider one oxygen atom. One oxygen atom has contributed 2 electrons to this bond, right? So covalency is 2. Coming to nitrogen right now. Clear ho raha hai na? Nitrogen right now. Please do slowly, there is no hurry. So nitrogen is having electronic configuration 2, 5. So 5 electrons are there. So it will need 3, right? So it gets added and here is the nitrogen. So if you see this nitrogen now, it is having 8 electrons, right? 6 plus 2. This nitrogen is also having 8 electrons. How many electrons had participated in this covalent bonding? We can see 6 electrons had total participation in this covalent bonding. So it will be triple covalent bond. And what is the covalency? Covalency is 3, because one nitrogen has contributed 3 electrons in this covalent bond. Clear guys? I hope till now everything is clear to you. Already you have studied this in class 9th also, and for class 9 also these things are there. So class 9 people can also watch this lecture, because this is there. Till now whatever we are doing, everything is class 9 syllabus also. Okay? Now next topic is there will be certain conditions favoring the covalent bonding. ठीक है, conditions favoring covalent bonding. Conditions favoring the covalent bonding. ठीक है, so number one condition is valence electrons. Valence electrons. Normally the valence electrons in covalent bonding, for each element the valence electron should be in the range of 4 to 7, but there are exceptions. We have talked about it. Hydrogen is there, then your boron is there, aluminium sometimes goes for covalent bonding, lithium is there which also goes for covalent bonding sometimes. Okay, okay, beryllium also goes for covalent bonding. So these are exceptions basically. ठीक है, these are exceptions which goes for covalent bonding. ठीक है guys, so this is valence electron. So valence electron generally have to be in the range of 4 to 7, and definitely we are now sure that non-metals are going to go for covalent bonding, right? So covalent bonding is basically nothing but non-metal plus non-metal. This is covalent bonding. ठीक है, non-metal plus non-metal. In case of ionic compound it was metal plus non-metal. Next is ionization energy. See, we already know it will be the bonding between non-metals and non-metals. See, if ionization energy is low, then easily you can donate the electron, then it will become ionic bonding, it will not become covalent bonding. So ionization energy has to be high for covalent bonding. ठीक है, covalent bonding. Clear? Number 3 point is electron affinity, that is EA, right? You will write total electron affinity. Electron affinity has to be high, because if the electron affinity is not high, then they are not going to form the bond itself. ठीक है, because they need electron, they have to have some electron affinity. ठीक है. Next is electronegativity difference. Electronegativity difference is basically the difference in electronegativity of two participating atoms, that must be low. If it is high, then it will go for ionic bonding. ठीक है, if the electronegativity difference is high, it will go for ionic bonding, because there will be charge separation. We will discuss all those things. Okay, don't have to worry. Okay guys, so these are the conditions that favors the covalent bonding. ठीक है, see, Lewis dot diagram of various kinds of compounds is very important for these chapters. ठीक है, like hydrogen, nitrogen and oxygen, all these chapters Lewis dot diagram is very important. Next we will go for chlorine Lewis dot diagram. Let's go for chlorine. We have done already, 3 are done. So chlorine means last orbit it has 7 electrons, so it needs 1 electron. So this way you write, you already know it needs 1 electron, so you write this 1 electrons in the horizontal position facing the other atom. So it becomes easy for you, nothing else. Here we will show it like this, done. So this is the chlorine molecule, 2 electron is participating in the covalent bonding, so definitely it is going to be having single covalent bond, right? It is going to be having single covalent bond. So you can write it like this also, or Cl Cl. Okay. Orbital diagram is also there in the book, you should do that one also. We are not showing orbital diagram in this class. Okay. Next is water. So let's take water now. Hydrogen plus oxygen plus hydrogen. So this is water, H2O, basically we know that, right? By cross multiplication of valency you can easily find out what is water. So here there is only 1 electron, nothing to think much, and we know that oxygen is going to as this is having one electron, it can give only one electron for sharing. So definitely ऑक्सीजन के साथ इसका एक ही इलेक्ट्रॉन शेयर होगा, ठीक है, इसके साथ भी एक. सो ऑक्सीजन का बाकी जो 4 इलेक्ट्रॉन है ऐसे रहेगा, ठीक है. सो दिस विल बी लाइक दिस. So this is water molecule, nothing else. This is water molecule, ठीक है. Next we will go for ammonia. See, first of all, while drawing this one, you do one thing. Ammonia means nitrogen, hydrogen. You know that. So this is having 3 valency, this is having 1. So do the cross multiplication, you will get NH3. ठीक है, you will get NH3. Clear? So once you get NH3, basically in like this. This is the bonding that is going to happen. This you already know. So what we'll do? You will write it that way only. Nitrogen plus hydrogen. Hydrogen means 1 electron. Nitrogen के साथ एक इलेक्ट्रॉन लगाएगा. इसके साथ भी ऐसे एक लगा दो, ऐसे और एक. और नाइट्रोजन का रहता है आपका टोटल रहता है 5. सो 5 हो गया, देखो, ठीक है. नाउ यू कैन राइट इट लाइक दिस. नाइट्रोजन, हाइड्रोजन, हाइड्रोजन, हाइड्रोजन. हियर देयर इज 1 बॉन्ड, हियर देयर इज अनदर बॉन्ड, हियर देयर इज अनदर बॉन्ड. कितने इलेक्ट्रॉन हो गया देखो, 6. सो पुट अनदर 2, 8 हो गया अमोनिया मॉलिक्यूल. और यू कैन जस्ट राइट, और नो डोंट राइट दिस इफ इट इज नॉट आस्क्ड, ठीक है. H H H, ठीक है. क्लियर? दिस इज हाउ यू विल शो फॉर अमोनिया मॉलिक्यूल, ठीक है. Okay, next we'll do CH4. So C you already know, C 4 valency, H is 1, so like this CH4. So basically it will be this structure, right? So C ठीक है. So here on you have to write it like this. 1 bond, so like this, another bond like this, another bond like this. 1 bond means basically 2 electrons, nothing else is there, guys. So it's easy, right? Very easy. CCl4, single bond of carbon. Carbon has 4 electrons in its valence shell. 7 7. ठीक है. So you will get this C Cl 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 Cl. Clear? So this is how you have to show the electron dot diagrams. See, everybody is having 8 electrons. Everybody is so happy. Carbon 8 electrons, chlorine 8 electrons. ठीक है ना? Chlorine 8 electrons like this. Everybody is so happy with 8 electrons. ठीक है? So these are the ones that are in ICC syllabus basically. CBSE में इतना कुछ है नहीं. ठीक है? जितना करा दिया बहुत ज़्यादा ही है. Oxygen molecule we have shown. Carbon dioxide molecule we can show. Another one, carbon dioxide. So CO2 we can show. So for CO2 basically carbon. So we know what is CO2. CO2 is C double bond O double bond O. ठीक है? हाँ, कार्बन का 4, ऑक्सीजन का 2. ऑक्सीजन का 2 इलेक्ट्रॉन चाहिए, इसीलिए डबल बॉन्ड. ऑक्सीजन का 2 इलेक्ट्रॉन चाहिए, डबल बॉन्ड. कार्बन को 4 इलेक्ट्रॉन चाहिए, डबल डबल, 2 + 2 4 bonds. So see, like this you will show. So as here are 2 bonds, so I'll write like this, plus oxygen. I'll show here 2 bonds. Okay, here again oxygen. So here you can see carbon is having 8 electrons, oxygen is also having 8 electrons. CO2 molecule. Clear? So you have also done CO2 molecules right now. So these are the electron dot diagrams for various types of molecules that are required to be studied. Okay? I hope these are clear. Okay? So now we will be going for polarity of the molecules. Okay? Polarity of the bonds and polarity of the molecules. Important part. Polarity of the bonds and polarity of the molecules. So here you need to understand a lot of things that is dependent on electronegativity. Okay? That is dependent on electronegativity, not our negativity, electronegativity. Huh? So we will be understanding the polarity of the molecules. So polarity of molecules. ठीक है? See, basically all the elements, different elements have different values of electronegativity. ठीक है? In different scales. So normally we use Pauling scale. So in Pauling scale, every element will have different values of electronegativity. ठीक है? So let us just take two examples over here. Let us take hydrogen, single bond hydrogen, and I will take another one, hydrogen single bond chlorine. So in case of hydrogen, the electronegativity, and other hydrogen, the electronegativity is same. So as the electronegativity is same, there is no electronegativity difference. So in this case, there is no electronegativity difference is 0. Okay? So what is this bond actually? You need to understand this thing. What is this bond? What is electron? Nowadays we study that electron is a particle, right? Subatomic particle. But definitely I will say you, when you go to higher classes, electron is not a particle. It is a cloud of negative charge. It is a cloud of negative charge. So when you think this bond, that means 2 electron is cloud of negative charge, then it can be assumed like this. Okay? The cloud of negative charge. Now both these hydrogen atoms are attracting this negative charge with equal intensity. Why? Because their electronegativity is same, and electronegativity is the tendency to attract negative charge or electron. So you cannot write this cloud in class 10, but this is important for understanding the polarity of the molecules. So this is a cloud of negative charge that is there here. Okay, a cloud of negative charge is here. Now as both has same tendency to attract the negative charge, so it will be evenly distributed like this in between these two, evenly distributed. Okay? Now when we talk about HCl, okay, so definitely the electronegativity of chlorine is much higher than of hydrogen. So this charge, it is again 2 electrons only, single covalent bond. This charge or this cloud of negative charge will be much more towards the chlorine. So how does this cloud change? This cloud becomes like this. Okay? This cloud is much more towards the chlorine. So in this case, in the first case, if you see, there is no charge separation. Charge separation means that nobody is having extra charge. Everything is exactly equally shared. The electronic charge is equally shared by 2 atoms. So here you are getting no charge separation. As electronegativity difference is 0. Okay? Here what happens? Hydrogen loses some charge, some amount of charge it is losing. So it acquires a plus delta. This is partial positive charge. Partial positive charge. Okay, and it acquires a minus delta because it is having a little more electron clouds towards itself. That is partial negative charge. it is partial negative charge. So here there is charge separation, charge is getting separated from one another, right? So here there is charge separation, there is charge separation, clear? So here there is charge separation. So we are talking about bonds where there is charge separation, bonds where there is no charge separation. Okay. So where there is no charge separation, this kind of bond is called non-polar covalent bond. See, in this case there is no polarity developed. Polarity means one side positive, one side negative. This kind of things has not been developed in this case, but in this case polarity is definitely developed. So this is called polar covalent bond. So in polar covalent bond there will be charge separation between two participating atoms. In non-polar covalent bonds there won't be any charge separation between two participating atoms. Okay? So here E and D, that is electronegativity difference, is not is equal to 0. In fact it is more than 0, or yeah, less than 0 भी हो सकता है, but if you basically take the electronegative, more electronegative atom at the first one, then it will be more than 0. Okay? Definitely not is equal to 0, clear? So this is the difference between polar and non-polar covalent compound. Okay? Now there are other things also. See, the polar covalent compounds have charge separation. So this type of compounds are also soluble in polar solvents, like water. Okay? Polar solvents like water, because at this moment you will write, because like dissolves like, because this depends on lot of interaction which you have not studied till now. So you will study that in class 11th and 12th. Okay? In case of non-polar covalent bonds, okay, so we are still talking about bonds, not compounds, remember, we are still talking about bonds and not compound. I have written this for polar compounds, I have written this for polar compounds. Okay? So let us first discuss what are polar compounds and then we will come to this differences. Okay? So at this moment we are still with polar covalent bonds and non-polar covalent bonds. See, while we are talking about those bonds, there is a term called dipole moment. Moment, you know, moment is basically movement. So movement of electrons towards an element is called dipole moment towards an atom. So if we talk about HCl, then we have known the electron charges moved towards the chlorine. So dipole moment is shown like this, which shows that it is moved towards the electronic charge has moved towards the chlorine. Okay? The more electronegative atom. Clear? Electronic charge has moved towards the more electronegative atom. So this is how it is shown. So this compound, where you can see the dipole moment is on one side, is polar covalent compound. Where you see hydrogen, there is, if you check hydrogen, so there is no such dipole moment between this, because there is no electronic charge separation. So this is non-polar covalent compound or molecule. Now the important thing is CCl4. CCl4. See, first of all you need to know CCl4 has a tetrahedral structure. This is tetrahedral structure. Just the way I have drawn, it has a tetrahedral structure. Okay? You can take this as a, have you seen three-legged chairs? There are certain chairs which have three legs. So it is basically a three-legged chair, and this is the stand behind the chair, nothing else. That is tetrahedral. Okay. Now in this case, where the dipole moment will lie? So individually you have to check. So here the dipole moment will be towards chlorine, here also it will be towards chlorine, like this, like this. Now there are 3 downward dipole moments and 1 upward dipole moments. For these 3 downward dipole moments, there will be a resultant dipole moment over here, resultant. This resultant dipole moment, which is downwards, basically cancel out the upward dipole moment. Clear? Just give me a second. Sorry. This resultant dipole moments, what happens? It basically cancels out the upward dipole moment. So the resultant dipole moment of this total compound, okay? Resultant dipole moment of the total compound is equal to 0, because the resultant downward dipole moment is cancelled out by the upward dipole moment. Please write it down. The resultant downward dipole moment is cancelled out by the upward dipole moment. ऊपर में तो कुछ resultant है नहीं, एक ही है, ठीक है ना? Resultant downward dipole moment is cancelled out by upward dipole moment, and hence the total polarity of this compound, please write down, total polarity of CCl4 will be 0. Total polarity of CCl4 will be 0, and it is a non-polar covalent compound. So it has a polar covalent bond. Definitely, if you talk about these bonds are polar covalent, but the compound as a whole is polar covalent compound, guys. I hope clear, guys, right? This is very important example of this one, okay? So when you talk about polar covalent compounds, they dissolve in polar solvents. Non-polar covalent compounds, now you can write down over here, non-polar covalent compounds dissolve in non-polar solvents. ठीक है, non-polar covalent compounds dissolves in non-polar solvents. ठीक है, it is still didn't end. Okay, we have to continue. There are certain differences which are important over here. So I'll write them again, no worries. So polar covalent compound, here we will write polar covalent compound, and here it is non-polar covalent compound. Write it again यार, जितना लिखोगे उतना प्रैक्टिस. अच्छा, पोलर कोवेलेंट कंपाउंड चार्ज सेपरेशन होता है, नो चार्ज सेपरेशन. ठीक है, अच्छा, बट दिस इज बेसिकली इन केस ऑफ बॉन्ड. सो व्हाट यू राइट, टोटल पोलरिटी is not is equal to 0. Yes, total polarity is 0. ठीक है, clear? Next, these are soluble in polar solvents. Soluble in non-polar solvents. ठीक है, these are soluble in polar solvent, these are soluble in non-polar solvents. Then electrical conductivity. Aqueous solutions conducts electricity. No, it doesn't. It doesn't form any aqueous solution, man. How will it conduct electricity? Not possible. Doesn't conduct electricity. ठीक है. Here you write that polar bonds are formed between two dissimilar atoms. ठीक है, non-polar bonds are formed between two similar atoms. But remember, in case of CCl4, it is having polar bonds, but the compound itself is non-polar compound. Don't forget this, okay, don't forget this, please. Now we will be doing state, basically characteristics of covalent compounds. Characteristics of covalent compounds. So covalent compounds is a big chapter actually with respect to ionic compounds. It is not that small because it has polar covalent compounds, non-polar covalent compounds and all those things. Before you write the characteristic, small thing, I think I have covered this in periodic table, but still I will just. So if between two atoms electronegativity difference is more than 1.7, then the bond is ionic. Okay? If the electronegativity difference, okay, I will write mod, okay, mod is very important. So you have to take only the positive values, modulus, only the positive value. इससे माइनस करो उससे माइनस करो कुछ फर्क नहीं पड़ता है. So if electronegativity difference is not is equal to 0 but less than 1.7, then the bond is polar covalent. ठीक है? If electronegativity difference is equal to 0, then the bond is non-polar but covalent. ठीक है? Clear? So this is the summarization between these elements. Okay. Now characteristics of covalent compounds. Number one is they exist as molecules. They exist as molecules. Ionic compound generally exist as ions. Covalent compound exist as molecules held together by weak van der Waals forces. Held together by weak van der Waals forces. Held together by weak van der Waals forces. Clear? Next is melting and boiling point. Please write down, covalent compounds are held together by weak van der Waals forces, hence their melting and boiling points are low. Hence their melting and boiling points are low. Okay? So this is very important, this weak van der Waals forces term for covalent compounds. Then you write like with that only. So generally these compounds are either liquids or gases. There are very few solid covalent compounds. There are but very few. Okay? Solubility we have already covered up, right? Solubility. You can write it again. Polar covalent compounds are soluble in polar solvents. Non-polar covalent compounds are soluble in non-polar solvents because like dissolves like. So I cannot really explain at this moment how can like dissolving like this thing, this is a statement, because this can be only explained after you go through class 11th and 12th. Okay? Achha. Next is electrical conductivity. Okay? Electrical conductivity. In case of electrical conductivity, please write down, aqueous solution of polar covalent compounds conducts electricity. Non-polar covalent compounds does not conduct electricity. Okay? Now somebody may ask me that what are non-polar solvents? You can write examples like benzene. Carbon tetrachloride is itself a solvent, non-polar solvent. Okay? Benzene you know, C6H6. So benzene, toluene, these are all non-polar solvents. Carbon tetrachloride. Okay? In electrical conductivity also write, normally covalent compounds are non-conductors of electricity because they don't have any ions, right? They don't have any ions, and for electricity you need free ions, full stop. For electricity we need free ions, full stop. When a polar covalent compound is dissolved in water, when a polar covalent compound is dissolved in water, due to its high dielectric constant, bracket में लिखो water, it breaks the bond splitting the covalent compound into free ions which conducts electricity. ठीक है? Okay, that's it, nothing more. So that is basically what it is. So if somebody asks you pure HCl is a non-conductor of electricity, what does this mean? भाई प्योर HCl मतलब उसमें कोई पानी नहीं है, पूरा प्योर है. But electricity conduction requires two things. Either you need free electrons, which is available in case of metals, or you need free ions. So in pure HCl there is no water. You have to write it like this. In pure HCl there is no water. So there is no free ions from HCl. There is no free ions from HCl and hence it doesn't conduct electricity. ठीक है? Also write down another question. NaCl has a high melting and boiling point with respect to carbon tetrachloride CCl4. NaCl has a high melting and boiling point with respect to carbon tetrachloride CCl4. ठीक है? So there your answer will be NaCl is a electrovalent compound held together by strong Coulombic electrostatic force of attraction, and hence it has high melting and boiling point, full stop. Next point, CCl4 is a non-polar covalent compound held together by weak van der Waals forces and hence it does not have high melting and boiling point. ठीक है? So after this what I will do is I will give you a worksheet. ठीक है? After this, along with this video I will also give you a worksheet. So you can, after watching this video, you can solve that worksheet and we can also discuss in our live session in the weekend. Thank you guys.